In this video, I'll be presenting few of the components of the end-to-end modeling with the deep learning, and this is my Git file, and where I have added few of the features like the main problem statements of the task of the classroom assignment, where I'll be demonstrating all the features like classification, regression, and image classifications, and for each of them I'll take a data set and I'll go through the loading the data set and training, validation, and evaluation, and etc. So, and along with that, I'll show the accuracy, precision, recall, and other ROC and other examples like how the matrices are displayed. So let's go through the one by one. So this is the data explanation of the my GitHub file, where I have mentioned about the what are that artifacts, matrices model, and which data set I'm using for the classification or regression task, as well as here I'll be providing the YouTube link for this video. And let's move on to the classification task. So to begin with the classification, first I'll install the VanB. So it's a kind of visualization tool. It's third-party system where we can see the weights and biases of the particular model. So here validation loss, and I'll come to this later part. And so here I have imported my initializing libraries and importing stuff, and here I have initialized the vanb. Make sure that runb is on the logs, so we have to sync that logs, and there is a API key for it. I think we have to enter it while we run this vanb.image files. And once this is done, then we have to load the dataset. So I have used a breast cancer dataset for this, and pose building the neural network model for a simple MLP for a binary classification thing. And here is the training for the fitting models, and there will be total 50 approaches for this, and X-train and by train wise the validation split is 0.02. So that's the one. And after that, the plotting the training history for the accuracy and loss over the approaches, and this is the plotting accuracy and the loss accuracy, that is a loss model and accuracy model. And once that done, then this is the dense layer of my neural network. So this is the visualization of an entire architecture, like how this model is there, like how the entire model is having how many layers and input shape and etc. So this is about the model, dropout 1 dense is the 4, and dense 5 is the output we can see is the none as 1. And so here is the optimizations one. So here we can see the precision and the recall. So these giving the good results, like FM score is very close to 94 95. And here is a ROC curve for that. And this is the precision recall curve, about all the accuracy of it, and etc. So this is the final per class error analysis, displaying the misclassified examples. So here there are no misclassified examples found. So this model and the fitting as perfectly made by the how many it required, and at the last. So this is the validation loss and the validation accuracy and the loss wise, and these are the approaches it took us the time wise, and the parasitic carbon etc. for this. So this is the first task, that is classification is over. Now we'll move on to the regression task. So in the regression task also is pretty much same, the loading the data and initialize the van db. And this is the one, we can see the entire run phase here, on the whole in extension phase, where here is the validation loss and MA and R2 score and etc. So I have performed few other tests for the regression basis. So by building the neural network for the NLP regression, and these are the splitting data and etc. And the training, the model will be performed here, and the plotting the history of a training and the validation loss versus the training and validation main square error one, validation of approaches and etc. And this is the architecture for the regression model. So, and post that, evaluating the regression score, here we got MSc and TS, MA and R scores, R2s, square error, root mean square error, that means. Then the visualization prediction versus actual value. So this is the one which is very close to the answer. And RMSE is the one, and root mean square, and mean absolute square error. And this is about the regression model. And once this is done, we'll move on to the last part, that is image classifying task. So here in the image classifying task, so we'll be having loading the data and the tensor board as well. So we'll load the CAF data set, like we'll be loading in this. So class names will be aeroplane, automobile, and bird, and etc, etc. So this builds the CNN model, that is flatten and the dense layer, like how many dense layer I want, and the dropouts and etc. So this all will be performed in this cell. So and here you can see the flatten and max pull and the dropouts and how many dense layers are there inside it. And this is the model fitting layer, where we'll be training the model using the validations and etc. And post that, like the same validation loss and the training loss. And this is architecture for this model, where this is a multi-neural one. So it has many layers inside it, the batch normalization one, then the conversion 2D, and the etc. Then the second layer, third layer wise the one. And like at the last, so this is the one, like the entire table you can see. And this is the evaluation model for this. And this is the confusion matrix we got for this particular data set. And after loading, and this is the model summary for it. And I have loaded a tensor board for this, like to try out like how it works and etc. So this is the biases history and the approaches, like how many approaches are there in this, and etc file. So this is the evaluation of loss versus iteration, and like how much time it took the to come up with that solution, and these are the losses for it. And this is the bias of histogram, like how the bias and variance are trading off in this. So this completes the entire file, like how I came up with the different approaches and I have solved with these three. So yeah, thank you. Let's see you on the next video.